This is problem 14 of chapter 11 called Lucky Guessing. So a friend of yours took the same test described in problem 13. So that was a multiple choice question or a test with 6 questions. Now your friend claims to have guessed blindly on every question. If the questions offered 4 possible answers, do you believe her? Okay, so run 10 trials. So let's think about this just a little bit. So the probability of success, if there's 4, right? If there's 4 questions, the probability of success is 0.25, or just I could say 1 out of 4. Okay, so the probability of failure is 3 out of 4, or 0.75. Okay, and the number of trials we want to run is 6. So the component, again, is just one multiple choice question. Okay, or answering it. Okay, and then the outcomes, once again, are going to be, let's see, correct or wrong. Okay, so let's see if we can describe how we would do a trial. So we will generate, so I'll say for each trial, we will generate, and I think once again we have to model 1 out of 4. Okay, so, or we have to model 25%. So we can use that with single digit numbers, and I'll explain why in a minute. So for each trial we will generate 6 random single digit numbers. Let's just say with the following assignments. Okay, so let's just say that we're going to let 0, that'll equal correct. Okay, and then 1 to 4, no, excuse me, my bad, wasn't thinking, 1 to 3, right? 1, 2, and 3 will be wrong. Okay, and then we will ignore, so from 4 to 9, we will ignore. That's how we would do that. Now on the calculator, you can just tell the calculator. You can say, for homework, you can do rand, sorry, R-A-N-D, rand int, and you can just do, 0 to 3, or you can do 1 to 4 for that matter. So it's a lot easier with a calculator, but I want to model it so that you understand how to do it for a test. Okay, so let's see, if we captured everything. For each trial, we will generate 6 random single-digit numbers with the following assignments. And we will count the number of questions answered correctly. Once again, we don't have to worry about a stopping condition. Some simulations we're going to have to worry about that, but not this one. Okay, so I think we got it. I think we have most of the details. So the question is, what are we going to compute? So once again, we're going to check to see if all 6 questions were answered correctly. All right, so there you go. Okay, and we're going to run. We could say up here we will run 10 trials. Okay, so our notation. C for correct, and W for wrong. You could, you could say a slash or something and a circle if you wanted. You could do slash for, or maybe a circle for correct and a slash for wrong. So there's different ways of doing it. So let's start trial 1. So this would be ignore. I'll put a slash through for ignore. Ignore, 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 ignore. And then this first question would be wrong, 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 ignore, 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 wrong, ignore, 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 wrong. 1, 2, 3, 4, 5. Ignore, ignore, wrong. Okay, so that was trial 1. Okay, trial 2. Correct. Ignore, 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 wrong. Let's see. Ignore, correct, ignore, correct, correct, correct. So we got 1, 2, 3, 4, 5, 6. So that was trial 2. Okay, so I'm going to stop the video here, and then I'm going to finish it, and then come back. Okay, I've gone ahead and run 10 trials, and you can see it's kind of messy. But if somebody was grading my test, so to speak, they could go through and they could see what I was doing. Because I use this notation, I cleaned it up a little bit. I said that a slash meant ignore. I should have said that. Now the response variable is kind of a weird on this one, because we're really checking, okay, to see for each trial. So you would almost have to say no, something like that, no, no, for all of them. It turns out that none of the trials had all 6 questions answered correctly. Okay, so now that's kind of our statistic. 0 out of 10 is 0, applies 0%. Okay, so according to this simulation, always write that. Now let's just make sure we're going to answer the question correctly. I always like to go back up and see, if each question offered 4 possible. Do you believe her? Do you explain basing your argument on a simulation involving 10 runs? Okay, so according to the simulation, we would expect her to get all 6 questions correct by guessing 0% of the time. Therefore, we do not or don't believe her. Okay, don't go beyond what we can say. Just keep it, don't say therefore she's a habitual liar or something like that. We don't have evidence of that. We don't know if she's what motivates her to say this. Maybe you're just so intelligent that she's just trying to show how intelligent she is or something, or crazy. Maybe you're crazy and she's trying to show how crazy she is. I don't know. It could be peer pressure though. So don't go beyond what the data can suggest. But we can say that we don't believe her. Okay, that's how you do these problems. Good luck.